5. We have to go from ready to start. 2, 1, 0. Booster ignition and liftoff of Shuttle Endeavour with NASA's final space station crew compartment that brings a bay window.
The rocket is being launched to space. Seems cool, right? But wait, isn't that bright hot flame causing damage to the rocket? Well, to be able to answer that question with confidence, we need to understand the basics of heat and mass transfer. Welcome to another episode of Crash Course. Today, we'll discuss heat and mass transfer. Heat transfer is the exchange of thermal energy between two or more systems due to a temperature difference, while mass transfer is the movement of particles from one system to another due to concentration difference. In aerospace systems, both heat and mass transfer play a critical role in the performance and safety of the vehicle. There are three primary types of heat transfer: conduction, convection, and radiation. Conduction is the transfer of heat through a material or between two materials in contact. And the heat transfer via conduction is dependent on the thermal conductivity of the object. That is basically the rate at which the heat is transferred by conduction through a unit cross-section area of a material. Thickness of an object and its area in contact with another object with higher or lower temperature and the temperature difference itself. Convection, on the other side, is the transfer of heat through the movement of fluid or gas. Just like you cool down your coffee by blowing air onto the mug, heat transfer through convection depends on the convection heat transfer coefficient. That represents the thermal resistance of a relatively stagnant layer of fluid between the heat transfer surface and the fluid medium. Area in contact and the temperature difference between the object and the medium that enables convection like air. Radiation is the transfer of heat through magnetic waves, electromagnetic waves. It is the reason behind Earth getting warmer due to the sun's heat, even though there is no contact and medium between the Earth and the sun. Radiation heat transfer is dependent on the radiation heat transfer coefficient, which is the rate at which an object radiates heat, area exposed to the radiation, and the difference of temperatures raised to the power of 4 between two objects. In rocket combustion chambers, heat transfer usually occurs through conduction. The combustion process generates extremely high temperatures, which must be managed carefully to prevent damage to the vehicle. Conduction occurs when the high temperature gas and flames come into contact with the walls of the combustion chamber and the nozzle, causing them to heat up and get damaged if continued like that. To dissipate this heat buildup and to avoid damage to the rocket body, a process called regenerative cooling is used. It involves circulating the liquid propellant around the rocket combustion chamber and the nozzle to transfer heat from the hot surface of the rocket body to extremely cool propellant. And this propellant is then pumped to the combustion chamber for combustion. And this answers our question: why does a rocket body or nozzle not get damaged due to excessive heat produced by it? And this ends our crash course. I hope you learned something new, and stay tuned for future episodes of the Crash Course.